Hello. Okay, so good morning, everyone. Today we are going to talk about Lab 4, yeah, about the linear regression. And firstly, please download the file, the Jupyter file from the notebook file from the OLE. And again, we will use the Colab. And we also have a txt file here for the data, okay? And you can just click it here and then right-click the page and click Save As to save the data. To download the data. Okay. Yeah. And after you've downloaded the two files, let's first upload the notebook as we did previously. And it should be yeah, so here is the file of the lab today. And we just connect the file. Connect the server. And then upload also the data set, the housing price, the housing data. Yeah, so we've uploaded here. And let's first have a look at the data here. So this is a very typical machine learning data set, which is called Boston housing price. So it has, the whole data set online should have like more than 500 data points with different apartments in this different district. And they have different kind of features for the apartment like here. And then the last column is the housing price. And all the previous columns represent for the feature of this apartment. And so each row represents for a simple, for a single sample. Yeah, so, and then we have in total 13 features. So there are 14 columns, right? 14 columns. And we have 13 features and one target value. So the last column is the target value, which is the median value. Wait, sorry. Yeah. The last column is the median value of the owner-occupied home in this. The unit is like $1,000. And so this is a target value of the housing price, the last column. And all these 13 columns represent for a single feature. So the first one represents for the crime rate of this district or this community, and like Second one represents for the proportion for residual land zones. I mean, should be over the size of 25,000 square feet. And like the proportion of the business center and the Charles River, if the house, I mean, if the apartment is close to the river, I mean, on the edge of the river or not. So it's like a dummy variable. It can be either 0, 0, or 1. And also there's something related to the environment, like the nitric oxide concentration. Okay, so it is like 一氧化碳浓度. And then it's like the average number of room per dwelling. Okay, about this. And age. So it's like the age of the apartment. And then like the distance from the employment center. And also like the location, if it is close to the radio highways, and it's like the full value property tax rate, property tax rate for the apartment. And also like the pupil teacher ratio, is like a student teacher ratio, and also the rate of black people. And the last one is the lower status of the population. This is like the population proportion of the population who has lower income. Okay, so these are the features of the dataset. And today what we are going to do today is that we'll use these 13 features to predict the median value or the price of the apartment. And firstly, we need to, again, import the packages that we need to use. Okay. And today we are going to use sklearn, this library. So this is very, actually very universal, I mean, popular library, sklearn, scikit-learn, I think. And scikit-learn here. It is a very popular library for machine learning, and it provides you different machine learning algorithms, different models, like showed here. And also it provides you the methods for data pre-processing and like evaluation of the model. So you can do other things in the sklearn with the method in sklearn library for machine learning. Yeah, and I think they only support the conventional machine learning method. Okay, so they don't have library for neural network, I think. So yeah, so this is a library for machine learning method. And okay, so let's start with the exercises today. So at the beginning, we need to read the CSV data. However, what we have today is a TXT data, right? So we need to have some changes here. So let's first put the name of this data. So before you load this data, please make sure that your data is already uploaded on the workspace, okay? Okay, and then we can define the header and the separator. We need to define the header and the separator. Header is header. Header. This I will explain later. And header, we don't need header. It is data set. This is separator. Yeah, and so we run it first. Okay. Parsing data. housing data. Oh, sorry. Yep. So when you use like data frame dot head, it will print the first 1, 2, 3, 4, 5 lines, 5 rows of the data. Okay. And here we define header as none. It means if we look at the data here, we only have the pure data. Okay, we don't have like the name of each column. So actually header means the name of each column. And if you define this header, let's see, you define this header as 0. We can see here the first column, the first data here for this first row is 0.006, right? And then if we change the header to 0, then it will use the 0, the row with the index of 0 to be used as the header. Okay, so we can try it here. And then we'll see that this first row disappeared because the first row is then used as header. So it is not involved in the data anymore. And also if you choose like the one, choose header as 1, then it will use the row with index of 1 as the header. And then the first row of data, I mean the index, the first row of data actually the second here. So 0.2, 0.0271, 0.02731. This will disappear. Like we don't have it. But if we put it down, then we'll again see this line here. Okay. So this just means which row you want to use as header. And here we give the name for each column because we don't have name. We don't have header. So we should give the name for each column, but this is not necessary. Okay. So just for demonstration and like for you to clearly understand which column represent for which feature, you can put header here. But I mean the name for each column here, but it is not necessary. Okay. And then we go ahead. We need to get the training. Sorry, the feature and the target value. So X here, as we talked in the lecture, X is the feature, right? And Y should be a target value. So let's define the feature. We need to give the location of the feature. Location of the feature. So we use all the rows. Okay, so the first element here represent for rows. Okay, it's like it means like 0 to end. Okay, something like this. If we just omit it, it means the whole rows. And then here for the columns, we use 0 to -1. Okay, -1 means the last one. So the last one is the median value. But you know, for in Python, I mean the last one you give interval. So the right one is open interval. So the last row is actually not involved. So when you put -1 here, it means this last row is excluded. So you are using this, the last column is excluded. So you are using the first one to the 13th one columns. Okay, you're using the first 13 columns as features. And then you leave one, you leave the last one as the target value. And then this is like the part of the table that we want to use as features. And then we need to get its values. We just use the value method. Okay. And then for this, target value. Actually, we can directly use its name. MEDB ETE dot values. Yeah, so this is one way. And you can also use another way. The same as what you do for the features. You can do like this, dot allocate. You can still use the allocate function, okay? So this is like doing slicing for array. And so in this time, we just want to use the last column. So we put -1 here, dot values. Okay, you can either, these two lines is like, you can either use this one or this one, okay? So let's first comment this one. We use this first. Okay, and then we are going to use the trim test split method, okay? Yeah, so this trim test split method is from the sklearn library, okay? So method for data preprocessing. And so we import from here, trim test split from the model selection. And what it did is that it split the it split the data set into a test data set and a training data set. Okay, so we have X and Y. X represent for features, Y represent for target. And then we split X and Y to training data set and test data set. We can see X train, Y train, X test, Y test. So firstly, we'll learn from this X train and Y train, the relationship between X train and Y train, to learn this function, this model of the relationship between these two variables. And then we'll use X test and Y test to test if the model is working well on new data. Okay, so this is why we need to do train test split. So every time you are doing machine learning, you need to split the data into training data set and test data set. So I've mentioned several times in the lecture, right? And then we just run it. And then, yeah, very simple. We are going to use the linear regression model. Okay. So, yeah, we just use this method, linear regression. Okay. This is to define a model of linear regression. Then we fit this model to the data. Just use this. So we define the model as this SLR, right? And then we use SLR, the defined model, to fit our data. Okay. So it's like a training process. When you are using fit, it means it is training the model with the data from X train and Y train, the feature and the target. And then, yeah, it's very fast because it's a very simple model. And then we just coefficient of the linear regression. And so you know that we have in total 13 features, right? So we will have in total 13 parameters plus the intercept, okay? So here is the coefficient, 13 coefficient for different features. Then let me find the lecture notes. Give you a better explanation on the definition of linear regression. Let me check right here. Yeah, so here. We can see when we're initializing the model, we are giving like random coefficient to the function that we defined. And then here, X means the features, and the theta means the coefficient, okay? So theta 0 is the intercept, and x0 is 0. X0 is 1. So this is not included in the coefficient. Actually, all the coefficients are here. Okay, and then what we are doing fitting is that we are going to find the best theta, group of thetas, to fit the model to the data. And in total, we have 13 features. So we also have 13 thetas. Okay, this is how it works. And I think there should be a attributes inside the linear regression model. Yeah, so it fit intercept. Fit intercept. You can choose if you're using intercept or not. Okay, so it's like right there. We have x theta 0, right? Theta 0 here means the intercept. So we can either decide to use intercept or not. Okay, intercept is the 截距. Okay, and by default it is true. Yeah, by default it's true. It will use the intercept like this to have the same value. And later I can change this one to show you like the difference. Okay. Okay, then we have the model. We need to use the model to predict on the new data, right? So y train predict is equal to y train predict is equal to, we use the x train to plot to predict y train. Okay, y train predict value, and then we use the x test to predict the y test. We use the training feature to predict the training target, and we use the test feature to predict the test target. Okay, and then we print out the MSE error. Okay, mean squared error means MSE. This is the loss function we use. Y train, and Y train predict. Y train predict. Yeah, Y train predict. So it's like we are calculating the MSE, mean squared error, between the Y train, this is the real value, the true value, and the predicted value. We're getting the error between this true and predicted value, okay? And then correspondingly, we also have Y test and Y test predict. I can just copy paste here. Y test predict. Okay, then we got the error. So this is like the error we got. We can see like in the training data set, we have like around 20 of MSE. And then in the test data set, we have 27. So it means in the test data set, it works worse than the training data set. Usually it happens. Okay. Usually the training data set, the test data set, I mean the accuracy of the, the loss of the test data set is worse. I mean bigger than the training data set, because the test data set is the new data. Okay, so you don't know about the data during the training. Usually the error is higher than the training data set. Okay, so this is how we do linear regression. Very simple when we are using these libraries. We just need to understand the procedure and the concept. Okay. And then let's talk about this range regression. So if you still remember that we mentioned the regularization, right? Regularization here, the last part. Oh, and one thing I want to talk about here is like when we are doing linear regression, by default, we are not using this gradient descent, okay? Because linear regression is a very easy model. So we don't need, usually we don't need to use gradient descent to find the optimal value. So by default, in this library, it is use least square method, okay? We didn't use gradient descent in this example. Then let's have a look at the regularization. Yeah, regularization here. We have two kinds of regularization. One is ring, one is lasso. Okay, it is also called L2 regularization and L1 regularization. So in the next example, we are going to use this L2 regularization. It is also called range regression when it's used together with the linear regression. So range regression just means you add a term in this linear regression formula. Okay. Just means we add an extra term like this of this one in the linear regression assumption function. And again, we need to define the model first. Range. So yeah, range as its name, range. The name is range. And then we have a parameter of alpha. This is a factor. This is the factor here. Okay, this is the lambda here. Alpha is the lambda here. So it's like how much, how powerful we give the, how powerful we penalize the loss. Okay, so this is the alpha or lambda. And then again, we fit this data. Okay. I'll just copy this right here. Right. We fit the X train and Y train. And then we calculate the coefficient of the linear regression. So we can see we have some different coefficient, different parameters as we have in the first example when we're using the range regression. And then again, we need to do these errors to predict, to evaluate the model. We need to use the model to predict the target values and then check the performance of the model. Okay, so you can just refer to the part here to do the part here. Okay, so I will give you 5 minutes for you to try to do it by yourself in this part, and then I'll talk about it. But they're the same. Okay, so you just need to understand what it is doing. Okay, then let's have a look. So again, to predict the Y train, we need to use the X train, right? The feature, we need to use the training feature to predict the training target. Okay, so X train here. And then for predicting the label or the target for the test dataset, we just need to use the X test. And then we are calculating the error. We're calculating the error between the Y train, the true value, and the predicted value here. And then Y test. Where's Y test? Y test. Y test. Also the error between the Y test, the true test value, and the predict tested value. Y test predict. Okay, so this is how we calculate the loss or the error for range regression. And then we can find that when we are using range regression, when we're using this regularization, actually the error is even larger than when we are using linear regression alone. Okay, so it means you don't need always use the regularization. So regularization is usually used to prevent overfitting. And in this data set, the relationship is quite clear. I mean, between the feature and the target, the relationship is not very complicated, and the linear regression can already fit this relationship very well. So you don't need to use regularization to prevent it from overfitting. Okay, and when you are using some more complicated method, more complicated model, and then because those model may be more powerful, then they will have kind of risk of overfitting. Okay, so this also means that linear regression in this case can fit this relationship very well of this data set very well, and it is very proper to use linear regression in this data set. And you can also change the alpha rate here, right? Now we are using 20. So if we are using 1, we can see, oh, sorry, yeah, we need to run this again. We're using 1, then we can see the result is closer to the original linear regression error, right? 20.145. We're using 20. It is 20.878. Okay. This is about range regression. And I forgot one thing here. So we can also try not using this intercept here. Okay, we set the intercept as none. And then, okay. Oh, sorry, should be false. False. We set the intercept as false. It should be true or false. Okay. And then we do this training again. Here, we already did. And then we evaluate the model. So we can see here when the intercept is true. So when we are using intercept, the MSE is 19.9 something, right? So now we delete the intercept. Then we can find that error is increased, become 22.4 something. Okay, so it means in this case, we need to use this intercept. Okay, we need to set it to true. You set to true, or you just delete it. You just eliminate it. By default, it is true. Okay. To become 19.9 again. Yeah. So this is all about the linear regression. Then the remaining time you're going to do some exercise here. There are in total 4 questions, but only one is about coding. Okay. The question is about like the theory. And then the submission link is already released here. Okay, and the deadline is next Monday, 17th of February. Yeah. Okay, now you have like 10 minutes to do the exercises today. And if you have any questions, please let me know. Okay, so if there are no other questions, it's the end of this lab. Thank you very much and see you next week.